Hey class, this is Mr. Quo, and welcome to another lesson on distance learning. We are doing the 6.2e lesson, creating cubes and nth roots. Okay, so this whole module we've been practicing simplifying square roots, and we know that simplifying square roots is usually finding a pair of numbers that can jump out of a root. You can realize that finding the cube root of something is going to be very, very similar to that. Instead of finding a pair, we are now going to find a triple. So let's get to it. It says find the volume of the cube. Describe the method that you are using. Okay. So the most important thing we realize is volume is three-dimensional. And since volume is three-dimensional, you basically have to multiply three of the dimensions, right? The first dimension that we usually work with is something we call, the length times the width. That gives us the area of something. And then the next dimension that we work with is, we call this the height of the object. Sometimes I like to use the word depth, but let's just call it the height of the object, which is this third dimension, the depth of the square itself, and that gives us the three-dimensional object, right? In order to find the volume of the cube, all you have to do is just do length times width times height. Okay, make sure that you always write units cubed when we're dealing with volume. Okay, so it's very, very quick. We know that a cube, by the way, is similar to a square because all of the dimensions are identical. Okay, so if the side length of the cube is 2, we know that the dimensions are 2 by 2 by 2. We know another way to write this is 2 cubed. We had squares before when we were squaring something. Well, a cube is basically when you multiply the base by itself 3 times. Okay, so this is going to be 8. And yes, you should be writing units cubed every time. Okay, here when we see it's a 5 by 5 by 5, I know that it's going to be 5 units. And I know that it's going to be represented as 5 cubed. Okay, here's 8 cubed. This is decently fast, so I'm going to go kind of fast. Each of the sides must have been 8 units. Now, does anyone know what 8 cubed is? If you said 512, that is correct, right? And then if the side length is s, you know that the volume would be s times s times s, where all the sides are the same. And you also know that the volume would be s cubed, right? So sometimes for a cube, you'll see some definitions. They'll literally write that the volume of a cube is s cubed, similar to the volume of a square being s squared, right? S cubed. This is going to be s cubed units cubed. Okay. If given the side length of a cube as x, what formula represents its volume? Kind of just wrote it right there. We use s here, but you could also use it as x. The volume would be x cubed. It would be x times x times x. If given the volume of a cube as v, what is the value of its side length? Okay, so it's kind of like if I gave you the volume of something, how do you then isolate the variable, right? If I told you that the volume was of a cube was 125, for example, right? It's kind of like asking you, what is the inverse operation to cubing something? Does anyone know? For squares, we have square roots. For cubes, we have cube roots, right? If given the volume, all you have to do is do the cube root of the volume, is going to equal the side length, right? If I take the side length and I cube it, then that will give me the volume. So similarly, if I take the volume and I cube root it, then I will go back and get the side length. Cube and cube roots are inverse operations. This entire year class in Math B Honors, we've been learning algebraic properties, algebraic principles. We know that if there's one route that we can go, if we multiply something, we also know that we can always go backwards. There's always an inverse operation to a typical operation, right? So if you want to multiply by something, you can invert it and multiply by the reciprocal and cancel it out. Algebra is all about canceling your previous operations. So it's kind of like learning the fundamentals of it. Okay, true or false? The square root of 9 is also the cube root of 27. First, you should know that the square root of 9 is 3. But what is the cube root of 27? So at this time, I'm going to go ahead and show you a beautiful list of all the square roots from 1 to 10. I have all the cube roots written down, and you should realize that all I really did was I just multiplied all of the squares by the 2 or the 3. 4 times 2 is 8. 9 times 3 is 27. 16 times 4 is 64. And you should have the perfect cubes written down somewhere, have them handy, because when we are solving for these, or when we are simplifying cube roots, just like we were doing in the square roots, you want to have all of these perfect cubes on the side. And that's the way I'm going to show you how to do it today. I'm going to show you multiple ways, but this is the method that I like best. So it's always important for you to know your perfect cubes. Now, notice that the perfect cubes do get really, really large. So you could almost say, like, from 1 to 6, you should know by heart. 7 through 10, you can honestly calculate by hand again. But so the cube root of 27 is indeed 3, right? It's kind of like asking you, what times itself 3 times will equal 27? And the answer is 3. Both values are equivalent. Okay. So as you can see, cube roots is not it's not really a new concept. It's just we haven't practiced finding the cube root of something, but you should realize it's very similar to finding the square root, except now you have to multiply, or you have to find the value that multiplies itself 3 times instead of 2. Okay, so I'm going to show you the traditional tree branch, factor tree, whatever you want to call it, method. But very soon, I hope you realize that there's definitely is a better way. So I'm going to show you the traditional way. The traditional way would be to use maybe something like, oh, the cube root of 8 times the cube root of 8 is going to equal the cube root of 64, right? And then you can keep extending this, but then you guys might also say, well, Mr. Kuo, wait a minute. Isn't the cube root of 64, isn't 64 a perfect cube? Right? Did we even have to extend this? No. We know that the cube root of 64 is just simply 4. 4 times 4 times 4 is going to equal 64. So you just have to get comfortable with the idea that, yeah, 64 is a perfect cube. 27 is a perfect cube. 125 is a perfect cube. Okay? So again, having these down, maybe before you even start the lesson, at this point of the lesson, if you need to pause and create a list like this, you should probably do that, because it's very important that you realize that these are very familiar numbers. Like the cube root of 28 is not going to be simplified. You can't simplify it, right? But the cube root of 27 can be simplified to 3. The cube root of 64 can be simplified to 4. The cube root of 343 can be simplified to 7. We're not going to ask you to simplify something that can't be simplified. So like if I asked you the cube root of 450, right? That actually wouldn't work with any of these. And I think the cube root of 450 is already simplified, right? So just start to be familiar with these numbers, okay? So if you are familiar with these numbers, then it makes this whole entire page decently easy, okay? Letter B, the cube root of 27 over 125 is really the cube root of 27 divided by the cube root of 125. And again, we know that these are perfect cubes. So this is simply 3, and then this is simply 5, 3/5. Okay, if you did 3/5 times 3/5 times 3/5, would you get 27 over 125? Yes. Okay, here you want to write this as a fraction. So you get the cube root of 27 over, now again, what is this? This is tenths, hundredths, thousands. And is it a coincidence that we gave you perfect cubes? No, it is not, right? So this becomes, now you don't have to write it like this all the time. You already know that the cube root of 27 is 3, and you already know that the cube root of 1,000 is 10. 3/10. Okay, obviously this takes a little bit of practice. I might be moving a little bit fast, and if you realize like, wow, Mr. Kuo, you're going a little too fast, maybe it's good to just pause and try these on your own, and then watch the video and see if you're doing it right. So at any point of the video, please be comfortable to pause. Okay, so for letter D, the cube root of 32, this actually is not a perfect cube. So there will be something stuck inside of that root, something stuck inside of that cube root, right? The cube root of 32, well, you can split this in half if you want, but that's not the best option, right? Let's use my strategy again. So we know that 32 is right around here. It's in between 27 and 64, okay? So then that means 32 is right here, and only if these three numbers, if one of them is a factor, then that means I can simplify this number. If it was this cube root of 33, then you actually would not have any opportunity to simplify the cube root of 33 because none of the perfect cubes are factors of 33 in my example. However, in this example, the cube root of 32, do we see the factor that would work with 32? Okay, if you said 8, that is correct. So then you get the cube root of 8 times the cube root of, well, what times 8 equals 32? 4. Now, typically, if this was a square root of 4, we would have realized that's a perfect square, right? The cube root of 4 is not going to be, you can't simplify it any further. This is already simplified. And the cube root of 8, well, we know that that is a perfect cube, and that's going to be 2, right? So then this final answer is 2 times cube root of 4. Now, typically, you don't have to use that dot, but I like writing it with a dot because I don't want you to accidentally think that I wrote 23, right? This cube root has to be like half the size of a regular number. And I use a dot here just to make sure you understand and everyone that's reading it understands that this is a product, but this is 2, a whole integer of 2 times the cube root of 4. Okay? Go ahead and try these two problems, and I'll give you a few minutes to try.